Welcome to GER Mathematics and Statistics lessons. In today's video, we shall be talking about the determinant of a 3 by 3 matrix by the method I'm calling the alternative method. So the determinant of a 3 by 3 matrix by the alternative method, okay? Now, before I begin, let me say a very special thank you to all our subscribers and those who are yet to subscribe. Please, if you haven't subscribed, please subscribe to the channel by clicking the subscribe button below. We are very grateful for your views to our videos, your comments to our videos, your shares of our videos, and your likes to our videos. We are very, very grateful. Please keep the subscription coming by telling people about GER Hub. The contents we offer are very, very great. Thank you very much for all you have done for us. Thank you and thank you. Now let's begin. So how do we obtain the determinant of a 3 by 3 matrix using what I'm going to call the alternative method? Let's begin with discussing that, okay? Now, the first thing I want to say is that using the alternative method, determinants can be obtained along any row or column of the 3 by 3 matrix. Okay? 2. The next thing I want to tell you about this method, even as I like the method so much, is that it becomes very complex to use the alternative method. It becomes very complex to use the alternative method when it comes to obtaining determinants of 4 by 4, 5 by 5, etc. matrices. Okay? So when you want to start obtaining the determinant of 4 by 4 matrices, 5 by 5 matrices using this method we are going to call the alternative method, it becomes very, very difficult to get, okay? It becomes complex. That is not to say it is impossible. It becomes complex to use, unlike Sarus's method, which is still efficient for obtaining 4 by 4, 5 by 5 matrices. Now, the third thing I want to say is recall that putting A in between two straight lines implies obtaining the determinant. So this was the notation for the determinant of A, which was also the same as writing DET A. Okay? So you hold on to that. Now, the fourth thing I want to say, please take note of all these things I'm saying, because put together they will help us in this video to understand the determinant of a 3 by 3 matrix using the alternative method. Now, every element in a matrix has a position sign. Okay? Now, so every element in a matrix has a position sign. Position signs for elements in a matrix begins at the topmost left hand element in the matrix. Okay? So position signs for elements in a matrix begins with the topmost left hand element in the matrix and is positive. So please take note again. Then the next thing I want to say is that from the positive sign at the topmost left hand element, or the topmost left hand position, from the positive sign at the topmost left hand position in the matrix, okay, the signs alternate. The signs alternate, okay? So minus, plus, minus, etc. Okay? Now I'm going to explain each of these things I'm saying. Now, the last thing I want to say is that corresponding to each element in the matrix is what is called a minor. Okay? Now, the minor, I'm going to show you how to obtain in this video. So, let's quickly go over all the things I've said so far. Number one, the first thing we want to do is we want to obtain the determinant of a 3 by 3 matrix by the alternative method. Okay? So, I am saying, in using the alternative method, determinants can be obtained along any row or column of the matrix. So you take note of that. It means that using this method, I can obtain the determinant of a matrix along any row or column. Point number two to note is that it becomes very difficult to use this method if it is a 4 by 4 matrix, 5 by 5 matrix we want to obtain. Okay? If it is the determinant of a 4 by 4 matrix or 5 by 5 matrix or 6 by 6 as, it increases. Okay? So it becomes very difficult when the order of the matrix increases from 3 by 3 to 4 by 4, 5 by 5. It becomes very difficult to obtain the determinant of a matrix when the order increases. Okay? Now, the third thing I want you to take note of is that remember the notation for the determinant of a matrix. Either for a matrix A, the determinant will be putting A in between two straight lines, or this. Okay? Writing DETA. The next one is every element in a matrix has a positive sign. Okay? Every element in a matrix, has a position sign. Every element in a matrix has a position sign. Now, the position signs for elements in a matrix begins at the topmost left-hand element, okay, in the matrix, and is positive. Now, I'm going to show you what that means. Let me come over here. Okay? So, this is what we mean. So, if I have a matrix A that is 3 by 3, let me put this A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay? Now, I want to interpret what I have said earlier on. Now, let's start with this. So, every element in the matrix has a position sign. So, and again, take note. Every element in a matrix has a position sign. And two, position signs for elements in the matrix begins at the topmost left-hand element, okay, in the matrix, and is positive. So it means that if this is the topmost left-hand element in the matrix, the position sign starts from here, and it is what? Positive. Now, the next statement I have made here is that from the positive sign at the topmost left-hand position in the matrix, what happens? The signs alternate to minus, plus, minus, etc. So from this positive sign here at the topmost left-hand corner, the sign alternates. So if this is positive, the next to it will be negative. The next will become positive. The next element to that will become negative. This will be negative, and this will become positive. This will be negative. This will be positive. This will be negative, and this will be positive. So it alternates like that. Okay? That is one thing I have said. Now, the next thing I want to tell you is about the minor. Now, you see every element in a matrix has a minor. How do you form the minor? The minor is the determinant corresponding to that element when you cross the element out. Okay? So, the minor of an element is the determinant. In this case, 2 by 2. The 2 by 2 determinant. So the minor of an element is the determinant, 2 by 2 determinant, that corresponds to that element. Okay? So I'm going to show you how that is formed. Now, let's see. So what that means is this. Take note. If I want to form the minor, if I want to obtain the minors of A11, the minor of A11, all I will need to do is to cross out A11. Do you see it? So cross out A11 and the minor will now be A11. The determinant of the minor of A11, MA11, will now be the determinant of the 2 by 2 elements, the 2 by 2 matrix there, A23, A22, A23, A32, and then A33. Okay? Now, if you want to form the minor of the next element, which is A12, you have to place this across the elements. So place this across the elements. You will end up seeing that the minor of A12 will be the elements that remain when you cross out A12. And what are you seeing? You end up seeing A21, A23, A31, A33. Okay? The minor of A13 similarly will be to cross out A13. Okay? See what I'm doing? So place this over A13 and place this. Crossing out A13 will leave us with this. Okay? So you see what is left. You will notice that what is left is A21, A22, A31, A32. So the minor of an element is the determinant of the elements remaining in the 2 by 2 matrix when you cross out that element. So this will now be MA21. The minor of MA21 will now be this. So all you have to do to form that is to cross out A21. So if you cross out A21, what are you left with? Take the determinant of what you're left with. That will be A12, A13, A32, A33. If you do that for MA22, you end up having this crossed out. Okay, cross it out. You end up having determinant of A11, A13, A31, A33. Okay? If you cross out A23, what are you going to have? You will notice if you cross out A23, this is what you're going to have. You are going to have the elements remaining. So take the determinants A11, A12, A31, and then A32. Okay? Now, if you want to get for A31, all you have to do is cross out A31. Okay? When you cross out, so MA31 will be to cross out this. Okay? So see what I'm doing? MA31, let me bring it over here. MA31 will be the determinant of A12, A13, A22, A23. MA32 will be, so if you cross out MA32, you end up having this. Okay? So this will be A11, A13, A21, A23. Then finally, if you cross out the last one, that is MA33 is what you want to get, the minor, that will be this A11, A12, A21, A22. Okay? So these are what we call the minor of each element. So when I say every element in the matrix, when I made this statement, that was what I meant. So corresponding to each element in the matrix is what is called a minor. So what is the minor? It is the determinant. It is the determinant of the 2 by 2 matrix formed by crossing out the element gives the determinant of that element, gives the determinant, gives the minor of that element, gives the minor of that element. Okay? So, the determinant of the 2 by 2 matrix formed by crossing out the element gives the minor of that element. So, what is the minor of A11? The minor of A11 is this determinant here, And how did we get that determinant? All we had to do was cross out A11, okay, and take the determinant of this here. How did we get the determinant? How did we get the minor of A12? Cross out A12, and what is left comes here, okay, this. Now how did we get the minor of A13? Cross it out. So when you cross out A13, this is what you have left, and that will be this, A13, okay? Now how did we get that for A21? Cross it out and take what is left in determinant, okay? So if you do that for all of them, you will see that every element in the matrix has a minor, okay? And the minor is the determinant of the 2 by 2 matrix that is left after crossing out that particular element. So that being said, if you can understand that every element in a matrix has its corresponding minor, then we can now use the alternative method. So remember, the alternative method can be used to get the determinant of a matrix along any row or column. Now I'm going to start with showing you how that works, okay? So let's start with taking A. So if I take A as A11, A12, A13, A21, A22, and A23, A31, A32, and A33. Now, the determinant of A, let's start with taking it along the first row. So along the first row. Along the first row. Let's assume that we want to obtain the determinant of this matrix along the first row. All you have to do is look at the signs. What are the signs of the elements along the first row? It will be plus, minus, and plus. Okay? Remember, the sign of every element in the matrix starts from here with a positive sign, and it alternates throughout the matrix. So, if you want to take the determinant of matrix using the elements in the first row, so this is what you do. I will take plus A11, okay, this first element, times its minor. What is the minor of A11? It is this matrix here. The minor of A11 is this matrix. Okay, can you see? So this will be A22, A23, A32, A33. Okay? Then I will bring the sign of the second one, which is minus. Then put the element there, A12. What is the minor of A12? The minor of A12 is this. Okay? So what is remaining? A21, A23, A31, A33. So you write it out here. A21, A23, A31, A33. Then come over to the last element. Remember, we are taking the determinant of this matrix along the first row. So this will be plus. So this will now be plus A13. Then bring its corresponding minor. The minor corresponding to A13 is A21, A22, A31, A32 in determinant. So I'm going to write this A21, A23, A31, A33. Okay? So, let's see again. So, this is A21, A22, sorry. So this is A22, then A31, A32. Okay, so I've corrected this. Okay, now that is if you wanted to obtain the determinant of this matrix along the first row. This is what you do. Now this will reduce to, remember, plus A11 is same as A11, so I'm going to write this times the determinant of a 2 by 2 matrix. The way we obtain it, it will be the product of these elements here along the principal diagonal, A22, A33, minus the product along the auxiliary diagonal, A23, A32, minus then A12 here. Obtain the determinant here. This will be A21 times A33. That's the product of these elements along the principal diagonal minus that along the auxiliary, A23, A31. Then plus A13. Obtain this A21, A32 minus A22, A31. Okay? This minus this. And that will be the determinant along the first row. Now, if you were asked to obtain the determinant along the second row, you can also obtain the determinant. all you would have to do is, again, look at the second row. What are the signs along the second row? So let's write again. So A in this case is A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay? Now, what is the sign along the second row? So along the second row, if this is plus for the first element here, this is minus, this is plus, this will be minus. So this is minus, plus, and then minus. Okay? So you will come again and say determinant of A will be the first element and its sign here. This is minus A21. What is the minor of minus A21? The minor of A21 rather is A12, A13, A32, A33. How do we obtain that? It is obtained by crossing out A21. Okay? Now, if you come over here again, you will notice that the next sign is plus. Plus what? A22. Put its minor beside it. So, how do you obtain the minor again? Cross it out. You will see the elements remaining in determinants. So, that will be A11, A13, A31, A33. Then, come to the last one, which is minus. So, this is minus A23. And the minor will be, again, look at it. You see? So that will be A11, A12, A31, A32. Okay? Now if you simplify again, you will still have this A21, A12 times A33, this times this, minus this times this, A13 times A32, plus A22 comes, then the determinant here, the 2 by 2 determinant, this times this, A11, A33, minus A13, A31, then minus A23 comes in here with the determinant A11, A32, minus, that is this times this, minus A12 times A31. Okay? Now, that is if you want to obtain the determinant along the second row. Now, if you want to obtain the determinant along the third row, you can follow the same procedure. Along the third row, if you were to obtain the determinant along the third row, let's bring the matrix again. A, this is A11, A12, A13. This is A21, A22, A23. Now, remember, here we want to use the third row to obtain the determinant. So, what will be the sign? Remember, this is plus, minus, plus, minus, plus, minus. So, what will this sign be? If this is minus, this will be a plus, this will be minus, and this will be plus. So, you bring it here. The determinant of A will now be, since we are looking for it along the third row, in this case, it was along the first row. Here, it was along the second row. Now, we are looking for it along the third row. Okay? So, along the third row, we would have this. So, let's see. That will now be, you bring A31, because it is a positive here, times its minus. The minor of A31 will be this. Okay, after crossing it out, that will be A12, A13, A32, A33. Then the next will be a minus sign, minus A32. Bring its minus. Its minus will be, the minor of A32 will be this. Okay, so that will be A11, A13, A21, A23. Then this will now be the minor here. The minor will be what is left. So that will be plus, because it has a plus sign here, A33. Then come over here. This will be A11, A12, A21, A22. Okay? And that will now give us, when simplifying, A31, because it is positive, times this, A12 times A33, minus A13, A32. Then bring your minus A32 here. minus A32 comes out A11, A23, this times this, minus this times this, A13, A21, plus this times this, A33 in bracket, A11, A22, minus A12, A21. Okay, so that will give us the determinant along the third row. Now, what if we wanted the determinant along the first column? Along the first column. So along the first column, you can also obtain the determinant, and that will be, let me write here, A equals A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, if you wanted to obtain the determinant along that column, what would you do? So all you would do would be this. You would start with taking this. So the interest here is this column. Okay? Now, when you take that column, it will give you this. Take note, the sign here is positive. This is negative. This is, so the sign here is positive, okay? Because it is the element that begins it. This is minus, this is plus, this is minus, this is plus, this is now minus, this is plus, okay? And this is minus, this is plus. Now, because we are interested in the first column, let's take the first column. So, determinant of A in this case will be, the determinant of A in this case, plus A11 times its minor. The minor of A11 is A22, A23. Just remember how we got that. Okay? So you cross out this. Okay? Now, then the next is minus A21. Minus A21 times its minor. What is the minor in this case? Notice it will give you A12, A13, A32, A33. Then plus is the next one. So, do you see it? That's the minor. So you end up having A31 plus A31 into bracket A12, A13, A32, A22, and then A23. Okay? That is when you cross out these. A11, A13, A22, A23. So that will give you this. So when you simplify, you end up having A11 because it is positive, A22 times A23 or A33, this times this, minus A23 times A32, then minus A21 comes in, A12 times A33, minus A13 times A32, this times this, minus this times this, then plus, what comes in here, A31 in bracket, this times this, A12 times A23, okay, minus A13 times A22. So that will give you the determinant along the first column. Along the second column, you can do the same, okay? Along the second column. So if you take along the second column, again, A is A11, A12, A13, A21, A22, A23, A31, A32, A33. So along the second column, what would it be? This case is this. This is the second column. So what will be the signs there? This is plus, this is minus, 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 this is plus. So what you are going to have here will be minus for this, plus for this, and minus in this case. So you bring out those elements. This will give you the determinant of A will now be, take the first element, minus A12, take its minor. Its minor will be A21. You check A23, A31, A33. Now notice again the minor of that element. You see? Then the next element is plus A22. So that will bring out this. Okay, so you end up having A11, A13, A31, A33. Then take the last, which is minus A32. Okay, so A32 comes out and its minor comes here. So what is A32? You will see it A11, A21, A23 here, and then A13. Okay, so this will now simplify A12 in bracket A21 times A33 minus A23 times A31. Okay, then as the simplification goes, A22 in bracket A11 A33 minus A13 A31. Then finally minus A32 in bracket A11 A23 minus this times this A13 A21. Okay, so what are we doing? We take each of them out and then multiply this times this minus this times this, this times this minus this times this, this times this minus this times this. Okay, now that is for obtaining the determinant of a 3 by 3 matrix along the second column. What if we wanted to obtain it finally along the third column? The third column. Okay, along the third column, it will now be writing the matrix this A11, A12, A13. Okay, A21, A22, A23, A31, A32, A33. Now, what will be the signs? This is the third column. Take note. You can obtain the determinant along the third column. Now, this is plus, minus. This is minus, this is plus, this is minus, this is plus. Those are the position signs. So for this one, it will be plus here, it will be minus here. Okay, so this is supposed to be plus. Okay, so this is plus, minus, plus, minus, plus, minus, plus, minus. So this should be a minus sign, and then finally this will be a plus sign. Okay, now that being said, let us now obtain the determinant of this 3 by 3 matrix along the third column. So that will be taking determinant of A to be plus A13, take the minor of that, minus A23, take its minor determinant, and then plus A33. Okay, so this will now be, if you take out this, you end up having the minor to be the determinant of A21, A22, A31, A32. Then if you take out the next, it will give you this. Okay, you end up having A11, A12, A31, A32. Then if you take out this, the last one will give you A11, A12, A31, A32. Okay, now if you simplify, that will give you A13 in bracket A21, A32 minus A22, A31. Okay, minus A32 or A23 rather, outside the bracket, this one. Then in bracket A11 times A32 minus this times this A12 times A31 plus A33 now in bracket A11 times A32 minus A12 times A31. Okay, so that will give you the determinant of a 3 by 3 matrix along the third column. Now, that being said, let us now take examples. Let's take examples of that. So in my example, I'm going to show you at random along the first row and possibly along the first column. So you do that for the other ones. Okay, you can use this. So I'm going to use an illustration here. Let's say we are given 1, 3, 2, 1, 6, 4, 1, 8. Okay, now the determinant of this matrix will be along the first row. If I'm using along the first row, 4, take note, this is positive, negative, and positive. So plus 4 is what I have here, times the minor, which is this, 1, 6, 1, 8, minus 1 times the minor, 2, 6, 4, 8. Then plus 3 times its minor, which is 2, 1, 4, 1. Again, take note, for 4, that is the minor, okay? For 1, that is the minor, 2, 6, 4, 8. And for 3, note, that is the minor, 2, 1, 4, 1, okay? So, now, that will give us 4 in bracket. 8 times 1 is 8. 1 times 6 is 6. So, that will be 8 times 1 minus 1 times 6 minus 1 in bracket. 2 times 8 is 16 minus 4 times 6, which is 24. Then plus 3 in bracket. 2 times 1 is 2 minus 4 times 1, which is 4. So, this will be 4. 8 minus 6 is 2. Minus 1 in bracket. 16 minus 24 is minus 8. Then plus 3 in bracket. 2 minus 4 will be minus 2, yeah? Okay? So that will give you 4 times 2 is 8. Minus 1 times minus 8 will give us plus 8. Then you have minus plus 3 times minus 2 will give us minus 6. Okay? So that gives you 8 plus 8, 16. 16 minus 6, that gives you 10. Now, if you were to obtain this determinant along the second row, okay? Let's assume we wanted it along the second row. Now, for the same determinant along the second row, what are the second row elements? 2, 1, 6. Now, note that the signs along the second row are minus, plus, and minus. So if I wanted to obtain it along the second row, I'll bring the first thing, minus 2 here, and take the minor of minus 2. The minor of minus 2 will be this, the determinant of 1, 3, 1, 8. 1, 3, 1, 8. Then I will take the next one, which is plus 1. So I'll bring plus 1 here in bracket. Then that will be, if you cross it out, 4, 3, 4, 8. 4, 3, 4, 8. Then the next one will be minus 6. So if you bring minus 6 here, you end up having its minor. What is the minor of minus 6? It will be 4, 1, 4, 1. So when you cross that out, you look at it again. 4, 1, 4, 1. So 4, 1, 4, 1. Now let's see if it will obtain the same result. So this is minus 2 in bracket. 8 times 1 is 8. 1 times 3 is 3. So that is 8 minus 3 plus 1 in bracket. 4 times 8 is 32. 4 times 3 is 12. Okay, so minus 12. Then minus 6 into bracket. 4 times 1 is 4. Minus 4 times 1 is 4. Okay, so that reduces to, let's bring our answer over here. 8 minus 3 is, so you have minus 2 here. 8 minus 3 is 5. Then you have plus 1 in bracket. 32 minus 12 is 20. Plus 20. Then you have minus 6 here. 4 minus 4 is 0. Okay, so you end up having minus 2 times 5 is minus 10, plus 1 times 20 is plus 20, minus 0. Okay, notice that 20 minus 10 is 10, and 10 minus 0 is 10. You end up seeing that we have the same result. Okay, that being said, thank you very much for subscribing to our channel. Thank you for watching this video. Thank you for your like to the video. Thank you for the shares of the video. Thank you very much. Thank you very much, and thank you very much. Please, you can try your hands on getting the determinant of a 3x3 matrix using this method called the alternative method. For this example, using the third row, the first column, the second column, the third column, just like I've shown you. It is easy. Thank you very much. Thank you very much, and thank you very much.